Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Ladies and gentlemen, I believe you are all well. Ladies and gentlemen, I want to take you through calculus for undergraduate. This actually it's for those who are in grade 12 who will be transiting next year to do their first year at university. And I believe, ladies and gentlemen, whatever I'm going to say here, it will benefit all of you. Right. Since now you know that you are in grade 12 and now you are writing your final examination in order for you to get a good pass, then so that you can do your first year at university, any university of your choice. Ladies and gentlemen, I want to take you through what is called the pre-calculus. Actually, we'll just call it calculus, which is the early this is the book that I was actually using when I was a university student. And this is by James Stewart. However, due to the editions might change. Right. Whether you'll be doing what is this? Engineering, whether you'll be doing engineering or any course where you'll be actually doing mathematics. It can be engineering, it can be in the field of actuarial science, it can be in the field of data science. It can be in the, as long as you'll be continuing with maths, then this is one of the module that you'll be doing, which you call it calculus. And this calculus actually has two branches. It's what we call the differential calculus, which is what we have done in grade 12. However, it will be added, a few things will be added, and also what is called an integration. And this symbol here that you see here on this book, this is called an integral sign. This is called an integral sign. So you'll be learning more about this when you go to university. However, ladies and gentlemen, now I just want to take you through the pre-knowledge. What is it that you need to know in order for you to enjoy your mathematics modules at university? Right. Without wasting time, guys, this is the book that I was using when I was an undergrad. And I believe that maybe due to different universities might use different textbook, but what matters most is the content. Usually it's actually the same. Right. Also in the issue of editions. And ladies and gentlemen, honestly speaking, whatever you have learned in grade 12, it's not about cram and pass. You need to also understand it, because you'll be also using this information when you go to university level. For example, if I want to take you through this, just a reference page, which I strongly believe that most of the lecturers will not gonna take you through this, unless if you're going to do a bridging program where you'll start with the pre-calculus, then they'll take you through these things. But on my side, ladies and gentlemen, I just want to at least remind you that whatever you learned in grade 12, you do not have to forget it. It's not about cram and pass, ladies and gentlemen. You need to also master this. And in the context of algebra, I know the author did not include a lot of things here, but just want to take you through some of the things that are very, very, very important. Remember, in the issue of algebra, you need to be able to understand algebra, particularly in the context of algebraic expressions, how to simplify fractions, and these are very important. How to actually simplify fractions, You have learned this in grade actually grade 12 and below, and other grades. For example, if you have, let's say, where you are dividing expression, we know when we have A divided by B, B also divided by C over D. We know in mathematics that we can change division to multiplication, which means we do not have to change the first one. Then we need to transpose this other one, should be D over C. Then we do the multiplication. This will be AD and this will be BC. Actually, the basic algebra, you need to make sure that you familiarize yourself with the basic algebra. It's not about cramming and pass and forget, guys. You need to make sure that you remind yourself with these things. And again, it is the issue of geometry. And some of these things, guys, are very, very important. The issue of geometry, being able to know, understand the areas, the circumference, which is called the perimeter, and also the issue of volumes. So these are things that you need to remind yourself, particularly for you to understand a lot of things when you're at university. Remember, most lecturers, they believe you know these things, you know this content, ladies and gentlemen. They strongly believe that you know this. So it means they're not going to spend more time in reminding you. They'll just use them. But you need to also be able to remind yourself. For example, when you're dealing with the triangle, we know when you're calculating the area of a triangle, it's half base times height. Or you can still use what you call the area rule. If you remember the area rule in grade 12, so which says it's half, then two sides and the sine of an angle. So if you're using an angle here, it means in a triangle, the triangle that you're using. So if you have A, B, and C. So let's say you want to use angle, just an example, you want to use this small letter B, this small letter C, and this small letter A. So if you want, let's say you want to use angle C. Obviously, when you want to use angle C, it means you must use the sides that has formed that angle C. That is actually called the area rule. Then again, there is the issue of a circle. Remember, the circle has what you call the area and the circumference. We know we went through this, that a perimeter and a circumference is one the same thing. But the perimeter of a circle is called the circumference, which is the total distance around the shape. Remember, in terms of this, ladies and gentlemen, we know the area of a circle, it's pi r squared. So obviously, if the area of the circle is pi r squared, what will be the circumference? The circumference will be 2 pi r. And what is the best way of remembering this? You can use what we have learned in calculus to say you can differentiate your area with respect to radius. So this is the change in area over change in the radius. If you differentiate with respect to radius, this will give us 2 pi r. So you see that from this you're getting this. So it means this is the circumference of a circle. Then also they will take you through what is called a sector of a circle. A sector of a circle has an area called half the square of the radius multiplied by the theta. And this theta, we'll talk about this, they said it must be in radians. In your calculator, if you can check in your calculator and a calculator on the screen, especially the scientific ones, it's either your calculator shows a D on the screen or it shows an R. So then R, this is called a radian. Usually in like at university, most of your angles will be measured in radians as compared to being measured in degrees. So you need to be able to know the relationship between angles that are in degrees and how do we convert them to a radian. So most of the angles in actually at the university level, they measure them in radians. So you need to be able to know that. For example, if we were to say, if you wanted to calculate the distance from here to here, which is called the S, the arc length, actually they call it an arc length, then it's r multiplied by theta. Actually, if you take this area and you differentiate with respect to r, if you take this area and say the area, it's half times the r squared times the theta. So this will become, if we make the derivative of an area with respect to the r, and this will give us, you see, the 2 will come down and it will become r theta. So this is what you need to know. Right, but it depends with universities, ladies and gentlemen. But as a pre-knowledge, whatever you learned in grade 12, you need to make sure that you understand them thoroughly, so you understand them. It's not a matter of cramming and pass. It's a matter of understanding what you are actually doing. Then another thing, ladies and gentlemen, is the issue of exponents. Exponents are very important. You need to familiarize yourself with the exponents. This is just a pre-knowledge where I strongly believe that most universities, unless if you are going to do a bridging course, but if you're not going to do a bridging course, they will not remind you this. They believe you know these things. And indeed, you have done these things from grade 12. So which means that you need to familiarize yourself with the basics. It's very important. For example, knowing the laws of exponents, that for multiplication, when the base are the same, we take one base and we add the exponent. For division, when the base are the same, we take one base and subtract. The issue of an expression that has multiple exponents. So an expression that has multiple exponents, you just multiply their powers or the exponent. Dealing with negative exponents. How about having two bases that have the same exponent? You can expand them. These are the things that you need to know when you, like, in order to enjoy your first year university maths. And I strongly believe you still remember some of the things. For example, we know that the nth root of these are sides of x. This is the same as x to the power of 1 over n. There it is. So these are the things that you need to familiarize yourself with, ladies and gentlemen. It's very, 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 very important. And again, however, in some instances, they will not, like, some things will be used, but you just have to remind yourself that when you have a sphere has a what? Has a volume of 4 over 3 pi r cubic. And once you take this volume of a sphere, you differentiate with respect to radius. It will give you the area. It will give you the area. So you see that by knowing calculus, then it's easier to know most of the things. So it means the area of a sphere, it's 4 pi r squared. So it's very, very, very important. Whereby if we take the volume, let's say the equation of the volume, it's 4 over 3 pi r cubic. Let's differentiate the volume with respect to the radius. So obvious, if you differentiate with respect to radius using your knowledge of differentiation, this will be 3 into 4 over 3 pi r to the power of 3 minus 1. And this actually will give you 4 pi r squared. You see, this is the formula for the area of a sphere. Then again, we have that one of a cylinder. But now with the cylinder, ladies and gentlemen, if we have this, then a cylinder has a volume of pi r squared h. And we know that when we are dealing with a cylinder, its surface area would be, if we assume that it is closed, it means the surface area of a cylinder will be the area of the circles, which is 2 pi r if there are 2 squared, plus then the side area, which will be 2 pi RH. And this 2 pi RH actually comes from when we've differentiated this. If you differentiate the volume with respect to R, it will give us the 2 pi RH, so which is actually this part. But since there are circles here, then we can still include that. So these are the things that you need to know when you are dealing with this, like when, in order for you to understand these shapes. This is just a pre-knowledge, guys. You need to familiarize yourself with these things. I'm not saying that you need just to cram, but at least know that whatever you have learned in grade 12, you must not forget it. You're still going to see it also at university if you're going to continue with maths. For example, in the context of factorizing polynomial, so we have things like the difference between 2 squares, x squared minus y squared, the difference between 2 cubes, and also the sum between two cubes. These are the things that you need to familiarize yourself, because at some university, ladies and gentlemen, they strongly believe that you know these things. You'll just see them applying them in their problems, but they will not explain to you where they're coming from. So they strongly believe you know these things. So make sure that you understand this. For example, we have something called binomial theorem. And I think this one, guys, the binomial theorem, yeah, they will actually teach you more about it when you go to university. But this is one of the easiest. Right, this has to do with, actually, if we look at this x plus y squared is the same as this if we expand it. This one is the same as that if we expand. This is the same as that one, and that is the same as that. Then when we have this, which is x plus y to the power of n, this is the same as x to the power of n plus the n x to the power n minus 1 times y. And this is the expansion. They'll teach you more about this binomial theorem when you go to university. This one, it's a guarantee. I'm telling you, they will teach you more about binomial theorem because you'll be using it time and again. So, but I will also create a video where I explain this thoroughly. So, then another thing, guys, is what we have already learned in grade 12, particularly under analytical geometry, the distance and the midpoints formula about the lines, knowing the issue of gradients, the slope y2 minus y1, which we know it's an average gradient. This under analytical geometry, you have done this. So it's not about cram and pass. And again, finding the equation of a line, y minus y1 equals to m into x minus x1. This is an equation of a line, or we can use y equals to mx plus c. Here they're just calling it b, but it's still the same thing. So these are things that you should know or familiarize yourself with. Then another thing, ladies and gentlemen, it is the issue of inequalities. What you have learned in grade 12 about the inequalities. It's very, very, very important. The inequalities are very important. There will just be a new thing that they're going to introduce to you, which is called an absolute value. So in the context of absolute value, an absolute value is just a value that is always, it's non-negative. So, like the absolute value actual always takes positive numbers. For example, this is a symbol for an absolute value. So if I say to you, what is an absolute value of -2? Obviously, the absolute value of -2 would be 2. Why? Because the absolute value is always non-negative. So it means the absolute value of -8, it's 8. This is called the absolute value. So which means that if you are just given this, if they say the absolute value of x equals to a, you must know, okay, it means that here it's either x equals to a or x equals to -a. Why? Whether you're using positive number or negative number, once you apply it inside the absolute value, since the absolute value is non-negative, and it means a positive value or a negative value always give us a positive value. So these are the things that you need to be able to understand. But if they say the absolute value of a variable is less than a, which means that we can say that value of x is a value between -a and a. I think this is what you need to understand when we're dealing with absolute value. Absolute values are always non-negative. For example, if we say to you to say, let's say we have a graph of sine. It's just an example. If we have a graph of sine, let's say at 0, at 90, 180, 270, it's just an example. Okay, 0 will be 0 if we are sketching the graph of sine. Then 90 will be 1. Then this will be 0. Then we're going to have -1. Then we're going to have 0. So which means the graph of sine would look like this. The graph of sine will look like this. So since this is the sine graph, we have learned this in grade 12. And remember, the sine graph from here, it will have a range of 1, and also it will have a range of -1. So it will have a range of 1 and a range of -1. But once I do this, I said, once we are given this or we are requested to sketch the graph of y equals to, then we put this. It means now we are sketching, okay, apologize, guys. It means now we are sketching an absolute function of sine. So we want to draw the graph, but for an absolute function of sine, which means if you want to draw an absolute function of sine, it means because this expression is now inside an absolute value, it means it will never become, it is a it should be a non-negative expression or a non-negative function. So it means if this one is for y equals to sine x, if we were to plot the y equals to absolute value of sine x, the graph will now look like this. The graph will now look like this. So it means you're going to have something like this. So it means it will become 0, and there it also become just like this. So it means this part is no longer negative. It will be that. So it means we are changing any values which are negative to be positive. So it means this is an absolute value graph for sine. So this is because it's 0, 90, 180 here, and 270 and so forth. So you see that this is now an absolute function of sine. So why are we using an absolute? It means now we are dealing away with non-negative values. So these are the things that we'll be seeing, particularly next year when they're talking about absolute values. So make sure that you familiarize yourself with this. Remember, don't panic. It's not like it does not mean that you're not going to enjoy these things, but I'm just giving you a background to say you'll be seeing things like this. Make sure that you understand how they work. So it means always when you are dealing with absolute values are always non-negative. They are non-negative, ladies and gentlemen. Absolute values are non-negative. For example, if we say to you, sketch the graph of y equals to x minus 3. Y equals to x minus 3, when we sketch it, obvious, this is a straight line, it will need the x-intercept. Obvious, with the x-intercept, you'll have to let y to be 0. So this will be 0 equals to x minus 3. You solve for x, then x becomes 3. Then the y-intercept will now be, if you let x to be 0, it will be 0 and minus 3. So if it means if we were to sketch the graph, then where is the x-intercept? It will be somewhere here. It will be 3 and 0. So for 3 and 0, then the other one will be 0 and -3. So it means the graph will look like this. But now, once we do this, ladies and gentlemen, remember this is 0 and -3. So, but once we say now, since this is the equation of y equals to x minus 3, now sketch the graph of an absolute value. You see, if we are sketching the graph of the same function, but now it's an absolute value. So it means we must get rid of the non-negative values. And to do that, it means, remember, absolute values are non-negative. So what does it mean? It means from this sketch graph, we only have to restrict where the function is negative. We change it to be positive. How? How are we going to do that? Let me show you. Guys, these are things that we'll be seeing next year. Don't be surprised. So you'll be seeing things like that. So you're going to have x there, and there you'll have y. So which means that where it was positive, we do not disregard that. It's still fine. But now we need to remember this is 3 and 0. So what we do, it means if this was 0 and minus 3, it will be now become positive. It will be this side, so which is 0 and 3. So it means the absolute graph now will look like this. So this is an absolute function of y. This is a y equals to the absolute function of x minus 3. I strongly believe you are now following. So these are the things that we'll be seeing them when you are at university, ladies and gentlemen. I believe you are following. I strongly believe you are following. So you need to be able to use these notations when you are dealing with absolute values. Then again, it is the issue of actually understanding the circles actually understanding the circle. Remember in grade 12, under analytical geometry, you learned on how to calculate the equation of the circle with center at the origin and with center not at the origin. But we're using this formula. It's x minus a squared plus y minus b squared equals to r squared. So the a and the b, this is actually the centers, which is the a and the b. So it means in this function, it's h and k, which are the centers, but the application is the same. The r is the radius. So these are the things that it's just a pre-knowledge, guys. Lecturers will not teach you these things. They will just have to apply them. They believe you know. Unless things like absolute value, yes, they will introduce them to you because they strongly believe that you have not done this in grade 12. Things like binomial theorem, they will introduce these things to you. But the issue of things like limits, differential, under differential calculus, they strongly believe you know these things. Like, for example, I know in most universities, usually during their first semester, they actually do more about functions, actually under functions, functions and graphs. Actually, because right now under the issue of function, remember functions speak of the input, and this input is actually called the x, which will give us the output, which speak of the y. So which means now you need to be able to know the function. For example, function of x, which means x is the input, which gives us the output. So one must be able to know like how to check if a graph is a function or not, how to check if a graph it is a function or not by using what you call a vertical line test, And remember, again, you must know that wherever we have a function, it's either it is a one-to-one or it's either a many-to-one. So it means a function can either be one-to-one or many-to-one. So these are the things that you will have to, like most lecturers, they will expect you to know this. And remember to check whether a graph it's one-to-one or many-to-one. What do we use? We use a horizontal line test. But you do this only when you have checked whether a graph is a function or not. Because if you're using a vertical line and your line touches the graph once, then you know this is a function. But a function can either be one-to-one or many-to-one. And how do you test this? You test this by using a vertical line test. For example, I apologize. You test by using a horizontal line test. For example, let's say on that equation of an absolute value of x minus 3, then you have this. You have the following. Remember, our graph was like this. Now, let's say we want to test whether this graph is a function or not. Obviously, we have to use vertical lines. Whatever the vertical lines, when you draw them, they touches the curve once, then it shows that this is a function. So it is a function. It is a function because the vertical line touches the curve once. But now my question is one. If this is a function, what type of a function is this? Is this a one-to-one or is it a many-to-one? Obviously, to check whether the graph whether a function is a one-to-one or many-to-one, we use a horizontal line test. So what you do, you draw a horizontal line on the graph. But if that horizontal line touches the graph more than once, then it means it's not a one-to-one, it is a many-to-one. So this is an example of a many-to-one function. Why many-to-one? It means now two values. If you can look at this, you can have two values here, which can give us one answer at the end. So you see that values of x, we have two values of x, which actually gives us one value of y. So it means they're moving from many to one. So they're moving from many to one. And remember, something that is not a function means it's not a one-to-one and it's not a many-to-one. It's a one-to-many. It is a one-to-many or many to many, but usually it's a one to many. Obviously, if we have a one to many, then this is not a function. It's not a function. It is not a function. So you have learned this in grade 12. Make sure that you familiarize yourself with these things, ladies and gentlemen. Particularly those learners who will be doing, especially will be hands-on mathematics, then you need to be able to understand this. You need to be able to understand this. Very, 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 very important. Because what I actually know is that in most of the universities, they do not actually, most of the things, it's just a touch up. Things that you have done in grade 12, they strongly believe that you know them and you know how to apply them. Very, 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 very important. Very important. Again, the issue of whatever you have learned in grade 12, the issue of knowing the issue of how to find an inverse of a function, very important. Inverse of a function, determining an inverse of a function. This is what you'll be asked. So you need to make sure that you understand most of the things. I mean, if you want to enjoy your first year university maths. For example, remember when you are determining the inverse, if you have y equals to x squared, when we are determining the inverse, remember inverse always do reflection about the line y equals to x. Reflection about the line y equals to x. So what does this mean? It means you have to swap the values of x and y. So x become y and y become x. Then from there we make x the subject, y the subject of the formula, which means when you have y equals to x squared, to determine the inverse, if this is the f, it means the inverse will be this. This is the symbol for inverse. So y become x and x become y. Then we make y the subject of the formula. So this will become y squared equals to x. Then we put the root sign here. Then your y would be plus or minus the root of x. These are the things that you need to be able to know when you are like during your first year, like as an undergrad. And ladies and gentlemen, it's not about cram, pass, and forget. It's about what you are like. They will be asking you these things. It depends with the course that you are doing. And remember at university, like we have something called specialization. You find that in the maths that you have learned in grade 12, that they actually divide it into two sections. Like things like Euclidean geometry, in most of the courses, they do not actually use it that more, but I'm not saying that learners must not be able to master it. And yeah, unless those will be doing civil engineering, if I'm not mistaken, but which will just assist when you're going to do drawing. And the other thing, ladies and gentlemen, is the issue of angle measurement. Yes, there's something that I wanted to add. Yeah. And another thing, guys, before we talk about the angle measurement, is the issue of using Socatrua. Is the issue of using Socatrua. Socatrua, this is very important. You need to make sure that you remember these things. It's not about cram, pass, and forget, guys. Socatrua. Right, we know sine its opposite over hypotenuse, and cos it's adjacent over hypotenuse, and tan its opposite over adjacent. But in grade 12, these things called the reciprocals. Reciprocals. I think these are, you have dealt with this in grade 10, if I'm not mistaken. But in grade 11, I mean, in grade 12, you never done these things of reciprocal. When you go to university, guys, you need to make sure that you remind you, like you know this reciprocal. Let me talk about them. Very important. Reciprocal is actually, if we know, look at this. We know that sine, according to Socatrua, sine is opposite over hypotenuse. And we know that cos, according to Socatrua, it's adjacent over hypotenuse. And we know that tan is equals to opposite over adjacent, which means the things called reciprocal. Look at this, reciprocals. It means what you do, we change this. Now we're going to talk about hypotenuse over opposite. hypotenuse over adjacent over. So we make like the reciprocal of this. Obvious, the reciprocal of sine, it's always called what you call the cosec. Cosec is the reciprocal of sine. Then reciprocal of cos, it's what you call the sec. You need to make sure that you know this. Reciprocal of tan, it's what you call the cot. The cot. That's why in grade 12, we do not actually focus more on this reciprocal. They are not there. But when you go to university, you need to make sure that you familiarize yourself with this. So reciprocal of sine, it's cosec. Reciprocal of cos is the sec, which is stand for secant. Secant. Then cosec, it's for cosecant. Then cot, it's a cotangent. It's a cotangent. It's called a cotangent. So this is called cot. So which means that if we know, for example, if we know that sine theta, it's 3/5, which means because sine, it's the reciprocal of sine is cosec. So it means cosec theta will be 5/3. It's just an example. If we know that cos of theta, it's 1/8. So it means the sec of theta, because sec is a reciprocal of cos. So it's going to be 8/1. So when we know that tan, it's, let's just an example, 1/2, it means the cot will be 2/1. That's why in most of the case, okay, we'll talk about this, but make sure that you familiarize yourself with this. I assure you guys will be seeing these things, the cosec, the sec, and the cot, particularly under calculus. So you need to make sure that you remind yourself with these things. Okay, guys, these things are very important. And also with the use of a right-angled triangle. Very, 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 very important. Very important. These things are very important, ladies and gentlemen. It's not a matter of cram pass and forget. It's a matter of understanding what you are actually doing. It's a matter of understanding what you are actually doing. Right, before I talk about the angle measurements, okay, it's fine. Let's just talk about the angle measurements because these things are very important, ladies and gentlemen. Right, at university, as I said, most angles, they're actually calculated in radians. From your calculator, we've got something called rad. Actually, in most of the scientific calculators, you find that if you don't check it well in grade 12, you find that it shows an R there on the screen. So this is an example of a radian. And this R in grade 12, remember, you're supposed to change it and put D. So this is called a degree. So now, at university, most angles are measured in radian as compared to degree. But what does this mean? It means when we write 180 degrees in degrees, this 108 is the same as pi in radian. So it means once you see a pi in radian, this pi is the same as 180 degrees. So which means when we have 360 degrees, it means in radians, in degrees is 360. So it means in radiant, it is going to be 2 pi. It will be 2 pi. So this is 2 pi. For example, if I have pi over 2, ladies and gentlemen, in degrees, the same as 90 degrees. Because remember, I said pi, it's 180. So, but if I say pi over 4, this will be 45 degrees. Why 45 degrees? Remember, pi, it's 180. So you're going to have 180 divided by 4. 180 divided by 4, which is 45. But how about pi over 3? Pi over 3, it's 180 divided by 3, which is just 60 degrees in degrees. How about pi over 6? Pi over 6. Pi over 6, I think this should be 30 because it's 180 divided by 6. This will give us 30 degrees. Then how about 2 pi? Let's say 2 pi over 3. 2 pi over 3. 2 pi is 360. So 360 divided by 3, this will give us 120 degrees. So how about 2 pi over 6? 2 pi over 6 is 360 divided by 6. This will still give us the 60 degrees because remember the 2 and the 2, yeah? We're gonna have this. So these are the things that you need to know. That's why in most of like in most of your like in trigonometry, especially at the university level. For example, if they want to sketch the graph for sine, if you want to sketch the graph for sine, remember in grade 12 we used to say 0, 90, after 90 is 180, 180 is 270, 270 is 360. So now at university level, usually they use the what you call the radians. So instead of for them to put 90, they will just write pi over 2. So it means pi over 2 is the same as 90. Then here they will put pi, but here it will say 360, I'm saying 270. What would be 270? Let's do this. Remember, 270 is the same as 180 plus 90. 180 plus 90, ladies and gentlemen. What is 180 plus 90? 180 plus 90 is 270. But in radians, we know that 180 is pi and 90 is pi over 2. So if we simplify this by applying the simplifying fraction, 1 times 2 is 2, then this becomes 2 pi, and that becomes the pi. You see, this gives us 3 pi over 2. So 3 pi over 2, 3 times 180 divided by 2. So this is going to be, they'll put 3 pi over 2 here. Then here they'll put 2 pi. So instead of putting 360 degrees, then they'll just put that. So these are things that you need to know, but the shape of the graph is still the same. There's no any different, but the only difference is that, sorry, they use radians instead of degrees, like in the context of general solution. If you recall very well from the general solutions, we used to say, for example, sine has how many answers? Sine has 2 answers if we want to determine their general solution. What is the first one? First one is the second function sine of a plus k times 360 when k is an element of integers. And the second one will be 180 minus the first answer plus k times 360 when k. So it means in the context of this, they will not write this as 360, they will just write it as 2 pi. So it means it's still the same application, but the only difference now they put 2 pi here. They put 2 pi here. It's only the same thing. But even here at 1/8, they will not gonna put 1/8, they'll just put pi to show that now we're dealing with angles are now in radiant. Angles are now in radiant instead of being in degrees. So you need to make sure that you familiarize yourself with this, ladies and gentlemen. It's not a matter of cramming, pass and forget, ladies and gentlemen. It's about like what you are doing. So which means that if you forgot what I'm actually explaining here, you can still revisit the videos, the grade 12 videos that I've already created, that can also assist you in remembering most of the things, particularly at the university level. So this is, to me, actually, this textbook was the best, like actually to me, it was the best textbook I've ever used when I was doing my undergrad. So these are the things that you need to familiarize yourself with. So that's why in most of the case, they will tell you that you are calculating like you like most of the angles will be calculated in radians. And again, actually the formula or the best way to convert degrees to radians or to convert radians into the degrees is to use this. Remember, 1 degree is the same as pi over 180. Because remember, pi is just 1/8. So it means if it is in radian, it will just be pi over 180, which is just 1 degree. So it's very important for you to be able to know that. So for example, if we were to use let's say I have 207 degrees and I want to convert these 207 degrees to what? To radians. It means I'll just take this 270 and I multiply it with pi over 180. Obvious, pi over what? This will be 270 pi over 180. And what is 270 over 180? 270 over 180. I think this will give us 270 divided by 180. It will give us 1.5. 1.5 is the same as 3 over 2. You see, it's giving us 3 pi over 2. It's giving us 3 pi over 2. So which means that all the time, for example, if we have 90, you want to convert 90 degrees to radians, so it's going to be 90 multiplied by pi over 180. You see, this will give us 2 here. It will give us pi over 2. So these are the things that you need to know. You need to understand how to actually convert from degrees to radians and also from radians to degrees. Very important. And again, guys, actually, let me just say this. Remember we said we have cosec. Cosec is the reciprocal of sine, which means to determine the cosec, they just short cosec, because the reciprocal of sine is just 1 over sine. So tan, we know it's sine over cos. And what is cos? I'm saying cot. Cot is actually cos over sine, which is the same as 1 over tan. Then again, you need to familiarize yourself with some things like this. 1 plus tan squared is the same as sec squared theta. And 1 plus cot squared theta, this is the same as cosec squared theta. And these are, it's what you'll be getting at university. For example, sine squared plus cos squared, we know this is 1. And this is just a negative angle. Obvious, negative angle is in the fourth quadrant. This become negative sine, positive cos, and negative. And look at this. This is the same as, remember, when they say sine pi over 2 minus theta. This is the same as saying sine into 90 minus theta. So it means you need to also familiarize yourself with the reduction formulae, ladies and gentlemen. But this time around, your reduction formulae should use radians instead of degrees. So remember, from the reduction formula, we used to have 0, 90, 180, 270, 36. Now we change and say pi over 2, pi, 3 pi over 2, and 2 pi. You see, when we say pi over 2 minus theta, it is in this quadrant. So it's where we have 90 minus theta. Obviously, it is in the first quadrant where sine is what? Where sine is positive, but because of 90, this becomes a co-function. So it changes and this becomes cos theta. That's why here they say sine of pi over 2 minus this cos theta, because this is the same as 90 minus theta. This is the same as 90 minus theta. Now, I want you see now we used 90 minus an angle on the tan. Why? Because now you know the reciprocal of what? Of tan. So which means the co-function of tan is cot. So it means when you have agreed, we know the co-function of sine in grade 12 is cos. But now the co-function of tan, now it becomes cot. And the co-function of cot, it becomes tan. So these are the things that you need to know when you are answering. For example, if we have, let's say we have sine of pi minus theta. Pi, we know it's 180. So 180 minus theta is in the second quadrant, where sine is positive. So it means this will just become sine theta, because it's not going to change. So these are the things that you need to familiarize yourself with, ladies and gentlemen, especially when you are dealing with radians. Most problems are in radians. So you need to make sure that you understand these things, ladies and gentlemen. These things are very important, particularly for first-year students. These things are very important, particularly for first year students. Sometimes they just write these things, but you end up not understanding where does these things come from. I'm going to find that lecturers believe that you have done these things and you know them. For example, a learner who's in grade 12 don't know that when you take 1 plus tan squared theta, this is the same as sec squared theta. Why? Because in grade 12, there were no reciprocal, but let's prove that. Let's prove that. Let's prove that. So when we have 1 plus tan squared theta, we know tan from grade 12. Tan is the same as sine over cos. So it means if it's squared, it means it's going to be the same. So it means we're going to say we have 1 plus, this is sine squared theta divided by cos squared theta, but that's over 1. So let's simplify fraction. You know how to do that. So we're going to have cos squared theta. We multiply the denominators. Then we cross multiply. This will be cos squared theta plus sine squared theta. But we know cos squared theta plus sine squared theta, it's 1. So it's going to be 1 over cos squared theta. But look at this. We know that sine, the reciprocal of sine, it's sec. How about the reciprocal of sec? It's cos. So it means when we have sec theta, it's 1 over cos. So which means sec squared will be 1 over cos squared. So it means this becomes sec squared theta. So that's why they say 1 plus tan squared theta is equals to the sec squared theta. Guys, the reciprocals, particularly at university, you must be able to know them. You must be able to know them. Most learners, they struggle because they do not know the basics. But since if you go through this video, you understand whatever I have explained to you, it will be easier for you to enjoy your first year university, especially in maths. Right. The other thing, ladies and gentlemen, is the issue of, okay, this one I believe you know how to use them. And okay, fine, sine, remember we can use this interchangeably. Opposite the same as y, hypotenuse is r. So we have done this. And the other thing is the issue of the law of the sine rules. You have learned this in grade 12. Sine rules, cosine rules, area rule. I'm not going to talk about that. So here it's what I was actually explaining to you. Okay, all right. You see here, this is the graph. Look at the graphs. The graphs particularly, you see that these graphs actually uses what? They use radians, not degrees. For example, you see that here, when I've done it 0, that's pi over 2, that's pi, that's 3 pi over 2, that's 2 pi. You see that now everything are in what? In radians instead of being in degrees. And again, you must be able to familiarize yourself on how to draw the graphs of this. You can even use your calculator to draw this graph. You can just say, okay, fine. We know that the cosec is the same as 1 over sine. So which means on your financial calculator, I'm saying scientific calculator, those who are in grade 12, you can just put this function as it is. But this time around, you need to use the angle from 0. It means it must range from 0 up until, let's say, up until 2 pi. Then maybe you want to increase your angle by, let's say, by pi over 2. Maybe you increase it by angle by pi over 2 as your step size. Then you're going to still see this kind of a shape. So you can still try to do that. But remember, in grade 12, in grade 11, I'm saying university, they usually use radians instead of degrees. So you need to make sure that you understand. Remember, for example, in tan, you remember a tan has asymptotes, right? Usually, if it's like this, it's asymptote, it's actually at 90 and also at 270, which means now it will be at pi over 2. And now this will be 3 pi over 2. I believe you guys are following. I believe you guys are following. So these are the things that you need to also familiarize yourself with. And again, the issue of what is this? The issue of compound angles and double angles that you learned in grade 12. Compound angles and double angles. These things are very important. Remember, like I said, it's not about cramming pass and forget. Remember, we have compound angle for sine, the one for the plus and the minus. Compound angle for cos, the one for the plus and minus. And also, there's a new one which is being introduced. There's a compound angle for tan. But usually in these instances, actually, usually if they want you to use this, then they will actually give it, they will give you like the compound angle for tan. Remember in grade 12, you never had compound angle for tan, but at university level, there are compound angle for tan. So I can even prove for you where does this comes from, but due to space, I think I might not complete it all. So it's like when we have tan of x plus y, we know tan is the same as sine over cos. Tan is the same as sine over cos, sorry. So you see now, it means now I have expanded this to be compound angle for sine and compound angle for cos. We know for sine, it's sine cos, cos sine, you know these things. So this becomes sine x cos y plus cos x sine y. Then divide by here, what do we have? We have cos, cos, sine, sine. This becomes cos x, cos y minus sine x, sine y. Guys, I'm not trying to frighten you. I'm not trying to give you that hope of saying you must not register maths anymore. No, these are easy, guys. It's just that I understand some of the things at first time, but once you familiarize yourself with this thing, you're going to enjoy. Right, then what you're going to do here is, let's do this. We're going to multiply everything. I'm saying we're going to divide everything by this expression here. So we're going to divide by the cos of x, cos of y. Any expression here, it means you're going to have sine x multiplied by cos y. We divide by cos x multiplied by cos y. Same applies here. Cos x sine y divided by cos x cos y. Okay, everything there divided by the same thing, cos x cos y. During our time at high school, we used to prove this, but I don't know what has happened. Then they took it out. Right, then now, okay, then we have this cos y. So I've divided everything by this expression here. So now look what is going to happen. Obviously, here the cos y and the cos y will divide. Here the cos x and the cos x will divide. Here cos x, cos y will divide. Then here none will divide. So it means you're going to end up having this. Look at this. We have sine x over cos x. This becomes tan x. Plus sine y over cos y. This becomes tan y. Then divide by, then this becomes 1 minus. This alone, this becomes tan x. This alone, this become tan y. So this is what, like, I have proved the first one. You can also prove the second one using the same approach. So these are things are just easy, but it's just the pre-knowledge which you are expected to know. That's why I'm saying, make sure you save this video. Don't forget to like, subscribe, and share. You save this video for next year, such that when you are starting with your first year at university, like maths, then if they talk about things, then you come to this video and refer wherever you don't understand. Then again, we have things like the double angles. I think you know these things. You have done double angles in grade 12. Remember, it's not about cram, pass, and forget. You need to know these things. So, for example, sine 2x, we know is the same as 2 sine x cos x. It's a double angle for sine. Then we also have a double angle for cos, which equals to 3 things. So it's cos squared x minus sine squared x, and 1 minus 2 sine squared x, and 2 cos squared x minus 1. So these are the things that you need to familiarize yourself with. And also we have a double angle for tan. People are surprised. We have a double angle for tan. Obvious, double angle for tan is straightforward. we know tan 2x is tan of x plus x. So which means if we come to this formula, remember here we have x and x, which means we are going to put x there, where there's y, put x. You see that x plus x, this will become 2 tan x. Then at the denominator will be 1 minus tan squared. So these are the things that you need to know. You need to know, ladies and gentlemen. Again, is the issue of being able to know what is called the half angles. And these were some of the questions which were asked in your grade 12 paper, but some of you were not aware of. So this is called the half angles. Half angles are also important. The half angles are also important. Half angles are also important. Like what I was saying here, like in the issue of trigonometric functions in terms of angles. Remember we said sine of 0 in radians is just 0. But in degrees, 30 degrees in radians is pi over 6. 45 is pi over 4. I think I spoke about this. So, but in degrees, sine 30, we know it's half. So these are the things that you need to familiarize yourself with. Okay, just a minute, guys. Okay, guys, I apologize. So as I was saying, the issue of half angles. Half angles means from the double angles. For example, if you have this, let's say you know that, for example, cos 2x, it's 1 minus 2 sine squared x. And you're looking for this. It means if you're looking for this will now become half of the angle. So it means we can make this the subject of the formula. So you're going to transpose it. It's going to be 2 sine squared x equals to, then we move this one, this side is going to be 1 minus cos 2x. Then we divide there by 2 and divide there by 2. So this becomes sine squared x equals to 1 minus cos 2x over 2. So these are examples of half angle. For example, you find that in the exam, they give you a right angle triangle. And this right angle triangle speaks of 24, but they want you to calculate, let's say, sine 12. You see, sine 12 means it's a half of 12, which means if you put 12 here, if you're going to say sine squared 12, then this will become 1 minus cos 2 times 12, which is 24. Already you have this, so you can, this is an example of half angles. So whatever you learn in grade 12, guys, you do not have to forget it. It's not about cramming, pass and forget. You need to also master these things for actually to be used in at university level, right? And again, ladies and gentlemen, yeah, this is just a knowledge. Don't worry too much. You learn more of these things when you go to university. So this is called calculus early transcendentals, and this was the 7th edition by James Stewart. This was the best textbook, particularly for me. I don't know for others, ladies and gentlemen. Again, so this was just a pre-knowledge. Let's go down. Okay, I want to check something, yeah? Okay, so I've already. So this is actually part one, but I will take you through other things that you need to know, particularly the limits, the derivatives, what you have learned in grade 12, and also to add other types of derivative, which you call them the product rules, the chain rule, the quotient rule, the power rule. So like, yeah, so we'll talk about this. Okay, let me just check something. Okay. Functions, yeah, the issue of functions and models. Okay, integration by parts. Okay, this is the different thing, which we'll talk about that. Sequencing series. Okay, the Taylor and Maclaurin series. Okay, partial derivative, but this one I think it's for second year. Okay, I just want to check something, guys. And again, before I forget, ladies and gentlemen, you must also familiarize yourself with the issue of transformations. Transformations are also important. About you remember we spoke about reflection about the x-axis, reflection about the y-axis, translating to the right or to the left. Those things are also important. They're very, 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 very important. You need to make sure that you familiarize yourself. But however, if you forgot some of the things, you can just go through my grade 12 videos under functions and graphs, then you try to remind yourself about those things, guys, because you'll be using them at university. I mean, if you want to get distinctions in your maths, so you need to make sure that you understand this. Okay, there's something that I wanted to check here. Okay, you see, this is just a test to check your level of understanding, but I strongly believe that you know these things. It covers what I was talking about: exponents, algebras, how to simplify expressions. I strongly believe you know how to do that. Like you see, simplifying fractions. Yeah, these are the things like solving for x. You see what I was talking about here. This is an example of an absolute value. It's an absolute value. So this is an example of an absolute value. You're solving problems that are involving absolute values, inequalities together with the absolute values. Then here are the answers. Here are the answers. Like, for example, if I wanted to cover in the context of inequalities, like, for example, if you want to say, you can try to do this to try to practice, for example, completing the square. So let's solve here. They said solve for inequalities for absolute value. So we know that when we have x minus 4, this is less than 3. So it means we're going to say the x minus 4 should be less than 3, or the minus of the x minus 4 should be less than 3. Then let's solve for x here. Then we're going to have x, it's less than 3 plus 4. So it means x should be less than 7. And the other one, let's multiply by negative minus x plus 4 is less than 3. Then minus x is less than 3 minus 4. So minus x is less than minus, then it means x should be bigger than 1. So if we draw a number line, it means we're going to say, okay, we have 1 and 7, which means when we say x is bigger than 1, so it means it's above 1 there. And this is below 7, so it means the answer it is in between. So it means the final answer is from 1 and 7. Why? Because look at what we said. We said when the absolute value is less than a, it means that your x should be between minus a and a. I think I spoke about this. So let's now check something here. If you check here, which question was that? You see its number. It says it's from between 1 and 7. So this is the answer. But some of the things you learn them when you go to university. But just as a background, this is just to check your level of understanding from grade 12. Like, are you able to factorize? Are you able to complete the square? Those kind of things are very, 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 very important. This is just a background, but if you are good with this, then there's no need to go through these things on your own. But if you feel like you want to do the practice on your own, you can still do it. And I think I'll also share. Okay, it's fine. It's fine. It's fine. One other thing is the issue of, remember the issue of solving inequalities. I believe you know how to solve this inequality. For example, inequalities that are involving fractions. How do we solve this? So we have 2x minus 3 over x plus 1 is less or equals to 1. Then you transpose this one this side. So you're going to have 2x minus 3 over x plus 1 minus 1, it's less or equals to 0. So that's over 1. Then now we're going to cross multiply. We have x plus 1. Then cross multiply. This will give us 2x minus 3 minus into the x plus 1. This is less or equals to 0. Then we're going to have, let's remove the brackets, 2x minus 3 minus x minus 1 over x plus 1. This is less or equals to 0. Then this will give us x minus 4 over x plus 1 less or equals to 0. But since this is at the denominator, it means x plus 1 should not be equals to 0, which means the x should not be equals to minus 1. So we can now do the critical values. Critical values we still include, this is going to be x equals to 4 or x equals to minus 1. So which one comes first on the number line? We have minus 1 and 4. So give me any value bigger than 4, 5. If you plug it here, 5 minus 1, it's 4, it's 1, so it's a positive number. Then 5, so it's a positive. So positive divided by positive is positive. And we know if it's positive here, then we're going to have negative, and then we're going to have positive. So what is our answer here? Our answer will look where there is a minus. So it means the answer is in between. It means the x, it's an element from minus 1 up until 4. But 4 we included, so in a closed brackets we're including. Or another way we can say x is between minus 1 and 4, but we are not including 4 because minus 1 because it's at the denominator, but we're including the 4. So that is the answer. So these are the things that you need to know, but remember, it's not a must to go through this, but if you want to learn to increase your knowledge, then you can. You see, it says it's from minus 1 up until, here's the answer. That is 9e. 9e, it says the answer is from minus 1 up until 4. I used to do these problems on my own, just to remind myself about, like, in most of the things, you know, because at the universities, these things, guys, are not being given to us anymore. So you just have to get the answers on your own. But you might be lucky. It depends with the universities, guys, because some universities actually they explain everything, but it depends with the universities. I'm not saying that you're not going to see this, but make sure that you familiarize yourself with these things. And again, guys, you see, we can, like, for example, you see, this one is just saying you need to prove whether these two things are false or true. For example, number A, it's not true, because if you have to expand this will give you, if you have p plus q in all squared, this will give you the p squared plus the 2pq plus the q squared. You see, it's not the same as this, so this is false. And this is true because the square root of a times b, we know this. But when you work out this and this, do you think they'll be the same? No, it's not the same because this thing and this are not the same. Because if it's like this, like we have divided these two, which is wrong. Now about these two also are not the same. This is false. Now about this and this, are they the same? Let's check. They can't be. They can't be the same because let's simplify this. We multiply this will become xy. And this become y minus x. And so obvious they are not the same, it's false. So you see, practice makes perfect. But it's not a must. If you know most of these things, then there's no need for you to remind yourself with these basics. It's not a big deal. It's not a big deal. Yeah. And again, what is the other thing? Yeah, inequalities, rationalizing the denominators. I think these are just the basics, guys. These are just the basics. Then in the issue of geometry, look at this. They say, find the equation of the line that passes through this, which has a slope of -3. You see, you have the gradient and you know the point. You say, like this one. Look at this. It says, determine the equation, the center and the radius of the circle. Obviously, you'll have to complete the square here to know the coordinate of the center and the circle. Completing the square. I think we have done that in grade 12. Completing the square. When we have different points, calculating the slope, the gradient, the equation of the line, the midpoint, the line of segment, equation of a line perpendicular, those are straightforward. For example, if you recall from your grade 12, how were you completing the square here? If you recall very well. When you're completing the square, what you do, the coefficient of x squared and y squared should always be 1. And if you want, then you take the coefficient of x and the coefficient of y. What is the coefficient of x here? Coefficient of x is -6. Then you multiply this by half and you square it. Then you're still going to do this. This will be half of 6 is 3. Then this gives us 9. Then same applies here. Coefficient of y is +10. You multiply this by half or you divide by half. Half of 10 is 5, which gives us 25. So which means the equation now would be x squared minus 6x plus, then you add the 9 here, plus y squared plus 10y, then you add the 25. Then you transpose 9 this side, so it's going to be -9. Then the one you added here, which is +9, again plus 25. So this will give us squared here, and we're going to have squared there. And this will just give us 25, which means the x there and the x. So the factors is this. So you're going to put -3 there, and there you're going to put +5. You see that the centers here, the centers is 3 and -5. And what is the radius? Remember, this r squared is 25, so it means the radius is 5 units. So we got the center, and this is what we have actually learned in grade 12, but it's just the basics, ladies and gentlemen. Again, the issue of being able to understand the inequalities, very important. The inequalities are very, very, very important. And again, yeah, this is just an example. So you see, we got the center to be 3 and -5. 3 and -5. It's not about cram, pass, and forget, guys. You need to be able to find, you see, the 3 and -5 and the radius of 5. So you still have to know these things just for your own good. Just for your own good. Remember, some things are helping you so that when you are attending their lectures, then when you are there, it's easier to understand what they're actually doing because you have learned this, you know them, you master. It's not about cram, pass, and forget. So it's very important. So this is just a pre-knowledge because I have not started with the university things, but this is just a pre-knowledge that everyone must make sure that you understand this. And again, the other thing is the issue of functions, guys. The other thing is the issue of knowing the functions, be able to determine the domain, be able to sketch the graphs. And these things, some of things, number 7, this is an example of function called composite function. I think they will also explain this to you next year. It's something called a composite function. Yeah, we call them the composite function. Inside a function, inside another function. So when we have something like this, f o g, this is the same as f inside like the g of x is part of f. So it means inside the f, you have to put the part of f of g. So for example, if the f, look at the f is this one, now the g is this, it means inside the f, you're gonna put 2x minus 3, which means where there is x inside f, we need to put 2x minus 3, which means the equation now, or the answer would be, it's called the composite function. So this will become 2x minus 3 squared. We substitute where there is x by this, plus 2 into 2x minus 3, then minus 1. Then we can expand this. This will give us 4x squared minus 6x minus, which is minus 12x plus 9. Then let's remove brackets. Here is going to be 4x minus 6 minus 1. In a standard form, it means you're going to have 4x squared minus 8x, if I'm not mistaken, yes. Then, which will give us 9 minus 7. This will give us 2. Give us 2. So see, the answer is 4x squared minus 8x plus 2. But if it's g, sorry, if it's g of f, so it means the f should be inside g. The f should be inside g. So it means here we're going to put x squared plus 2x minus 1. So it means we do the same. We do, so this one is g of the g of another g. So it's several times. So g of the g of another g inside. So these are the things that you need to know or familiarize yourself. What I think this is number 7. So if you look at number 7, here's the answer. I think you can easily see that I got it correct. So this is called composite functions. Composite functions. These are composite functions. And like, look what it say. Like if they say, so this is just the basics, ladies and gentlemen. So you need to make sure that you familiarize yourself with what I've already told you. For example, if we were to look at this, if you look at this, they say, how are the graphs of the function obtained from the graph of f? If you look at number f, now number 4, we know that when we have something like this is reflection about the x-axis. Again, we know reflection about the x-axis. X does not what? X does not change. What changes is the what? Is the y. Then look at this graph will shift 3 units to the right and 2 units upward. So you need to know the transformation. It means this will be enlarged or will be multiplied by a factor of 2. Then after that, it shifts 1 unit downwards. So these are the things that you need to know. You have done these things from from grade 12. So it's very important to understand these things. But this is just a pre-knowledge, guys. If you are good at these things, then there's no need for you to go through this. And the other one is the issue of trigonometry. Trigonometry, you see now they're saying we must convert degrees to radians. And how do you do that? 300 degrees to radians, it means you just say 300 multiplied by 180, pi over 180. And obvious, 300 divided by 180. So obvious 300 divided by 180, this will give us roughly 1.6. I think 1.6 it's 1.6 is 5 over, so this is 5 pi over 3. So 5 times 180 divided by 3. So it's 5 pi over 3. Then how about minus 18 degrees? To usually a negative angle, we convert it to what? To a positive. But if it's like this, means it's going to be, let's say, minus 118 multiplied by pi over, but usually a negative angle. So it means it's the one which is measured clockwise. So it means we can also consider the anti-clockwise one. So it's still the same thing. You see, it's the same as what you have learned. If they say sine, if sine 3 over, sine x is 1 over 3, and sec y is 5 over 4. Now, if the y x plus y is between 0, then evaluate this. Is this require a compound angle, but you must draw your right angle triangles because the set is from 0 to 90. So it means all your angles should be in the first quadrant. So you can start with that one of x. So opposite, it's 1, hypotenuse is 3, then you want to get the adjacent, then you also come with that one of the sec. Same applies. Remember, sec is the reciprocal of cos. Remember, sec, which is 5 over 4. Sec, remember cos is what? Cos it's adjacent. So it means this one would be hypotenuse over adjacent. So it means the R is 5 here. Sorry. And the adjacent it's 4. So you're gonna get the Y here. Then you use compound angle to get that. So here is just proving the identities, finding the generals, find the values of X that are between this. You see here you're determining the angles. You're determining the angles. For example, remember in grade 12, this is part of general solution. We have sine 2x equals to sine x. And we know this is a double angle. This is 2 sine x cos x. Then we move this one this side. Then now common factor, it's sine x. Here we're going to remain with 2 cos x minus 1 equals to 0, which means sine x it's 0, or 2 cos x it's 1. So sine x it's 0, or cos x it's half. By the way, this time around we're not using degrees. They must be in radian, but they said you must write the answer between 0 and 270. So it means with whatever we learned, instead of, we know that, for example, sine has how many general solutions, ladies and gentlemen? Sine has 2 solutions. And since sine has 2 solutions, it means here you're going to say sine x is 0. So it means the x would be 0 plus k times 2 pi, not 360. When k is an element, k or n. The second one is, remember we said the first answer in 180 minus the 180 will be pi here, plus k times 2 pi, when k is an element of integers. Then how about cos? Cos of half. Remember, cos has how many answers? 2, plus and minus. So it's going to be second function cos of half. What is second function cos of half? I think it's 60, if I'm not mistaken, in degrees. Okay, but we need to write it. Okay, what is cos? 60, it's half. But we're not going to put 60 here. Remember, 60 is the same as what? Pi over 3. So it's pi 180 divided by 3. So it means when I say plus minus pi over 3 plus k times 2 pi when k is of integers. But now we want the values, not the general solution, we want the values that are lying between here. So obviously to do that, we're going to start doing k equals to 1, K equals to 2, K equals to 1, K equals to 0, K equals to -1, and K equals to -2. Then we do the same. Okay, just so if you start doing that, it means now K, when K is 2, it means your answer will be out of bounds. So let's use 1. If it's 1 here, if it's K equals to 1, if you put 1 here, and then we put 1, and here we put 1. So you see that this will give us 2 pi. With 1, it will give us 2 pi. It will also give us 3 pi, but 3 pi, it will be out. And when you put 1 here, when you put 1, it will be 2 pi plus pi over 3. I think this will be 6 pi, which is 7 pi. It's 7 pi, 7 pi over 3. And what is 7 pi over 3? Remember, pi is 180, so it means if we say 7 times 180 divided by 3, it's a bigger angle, so we're not going to take it. So let's take the other one, 2 pi minus pi over 3, which is 6 pi minus pi, which is 5 pi over 3. 5 times 180 divided by 3, this is 300. So it's also part of 5 pi over 3. Then now let's put 0. If you put 0, it will be 0 there. If we put 0 here, we're going to get pi. If we put 0 there, this will give us pi over 3. I think this will be the answer. So we're going to say X is an element from, okay, right, is equals to, writing as I said, which one is the smallest? 0, followed by pi, pi over 3, followed by pi, followed by 5 pi over 3, and 2 pi, unless if I missed something. So this is actually the answers. Okay, so this is about trigonometry. Remember I said what matters most is to, yeah, you see, there is the answer. We got it all of them. So it's still the same application, guys, but just that you see 0, pi over 3, pi, 5 pi over 3, and 2 pi. Same application, ladies and gentlemen. All right, this was just the introduction, which I wanted to show you that whatever you learned in grade 12, guys, don't take it for granted. Whatever the information you have, make sure that you store it safe. You might need it somewhere when you are going to work with your, yeah, so you might need it. So make sure that you understand it thoroughly. Oh, by the way, I forgot to confirm to answer that last question. Remember we said -18, but still it's showing that the answer is minus pi over 10. But it's fine. You can also try that on your own. Remember, guys, I'm not trying to frighten you guys. I'm just trying to show you that whatever you learned from grade 12, you're still gonna use it in also at university. So make sure that it's not about campus and forget. Then now in the next session, I think we're gonna take you through the calculus, particularly on limits and also the derivatives. So yeah, thank you very much for listening, guys. Take care. Bye-bye.